So quickly, before I even start, I'd like to, thank DSC for having me on. This is probably my, I think my fourth year in a row where I've been doing these things, or at least on different DSC events. So, always a pleasure to be a part of it. Now, my name is Erik Ternav. I've been working at IBM for almost 3.5 years now, and my current role is a data and AI partner technical specialist. Okay, and the thing is that now my main job is to enable partners because we work a lot with our partners, and it's my main goal to enable them so that they are able to effectively sell and deploy IBM products, specifically products that are part of the data and AI portfolio from IBM. Okay. So in the last 3 years, I changed a couple of roles, but I've been in the data and AI landscape ever since I began. Okay. So I've been working with AI from the very beginning, and ever since generative AI became a thing, I started to work with these technologies from the get-go. Okay. So I have a lot of experience relatively how new the technology is. Okay, so initially I was also an AI engineer. So I had let's say, I had this nice experience where I was able to implement different projects, different POCs and MVPs across the region in Eastern Europe territory and the Nordics. And I got I got a pretty good technical background when it comes to working with such technologies. And then later on, I sort of transitioned to the pre-sales role where I'm currently located. So yeah, today I'll be able to show you and share with you some of the experiences that I personally had. And the main thing for today is I'm probably going to skip some of the presentation. And I also have a demo, by the way, which I'm going to show you in the end. But the main goal today is not to talk about the generative AI landscape, because I'm sure most of you, if not all of you, are aware what's currently happening, how it's an interesting time period that we're currently living in. So I'm well aware that most of you are quite knowledgeable on the subject. So I'm going to skip the generic sales approach. So we're going to go straight into the functionalities. But I'll have a couple of slides initially just to set the stage and give you a bit of information that I think is quite relevant to to 2024 and for the next year. Okay. So I'm going to be talking about generative AI for businesses with watsonx.AI. Okay. So generative AI essentially in a business context. Okay. So let's go straight into the first slide. Okay. So this is one of those slides which is a little bit, sales oriented. And I promise that I'm not going to touch, I'm not going to spend a lot of time on these slides, but here you can see essentially it's a scale of impact points to swift adoption over the next 3 years for generative AI. Okay, so the idea is that this is not just one of those generic hype technologies, but it is something that's going to stick, and it's easy to say that it's going to be a technology that's going to be relevant at least for the next decade. Okay, so it's not just a fad, it's not just a trend that's going to disappear in a matter of a year or two, but it's pretty safe to say that it's going to be here for a while, especially considering how many billions of dollars it's being invested in, as well as it's not an coincidence that NVIDIA surpassed Apple when it comes to value. So those are just some of the markers that points to the importance of generative AI. So the next slide is also similar to the first one. But here, as we can see, generative AI, now the most frequently deployed AI solution. Here, I'd like to point out this part, which says that 29% of organizations in the US, Germany, and the UK have deployed and are using Gen AI. Okay, now this is, I think it's an important piece of information. Why? Because considering the technology is fairly new, okay, so it's almost 2 years old, if I'm not mistaken, something like that, or at least when it became mainstream, it's almost 2 years old. It's in a business context, it was, it started to be, it was started to be integrated in different business processes about a year and a half ago or something like that. So having 29% of all organizations in Germany, UK, and US already using some of these use cases and have them deployed in production, that's a pretty big, pretty big step. That's quite fast if you take into account the time frame. Now, why is this relevant to let's say Eastern Europe and countries that are not part of these three, right? Why the relevancy comes from a trend which I also saw from experience, although more from other sources, believable sources that says that whenever it comes to IT, usually Eastern European countries and Central European countries tend to be a little bit slower compared to the West when it comes to adapting new technology. Now, why is that the case? There's of course multiple factors, but one factor is that we tend to, let's say, take a step back and observe what's going on in the West, okay? And not every new technology is a good idea. Not everything sticks. So we tend to observe, we see, okay, we're going to see whether or not the technology is actually useful, whether or not it's useful to invest so much money into a certain technology. And then if we see that it actually sticks, if it's working, then okay, it's time to adapt it locally. Okay, so we kind of like we use the West as a test and then later on adapt the things that stick. So but the issue here is, okay, it's a safer bet, but the issue here is that we're a little bit late to the party. And usually the delay is about at least 2 and something years when it comes to other technologies. Now, generative AI is a bit different because compared to, the average, technology that went through this process. And the difference is that I can see even from personal experience that even when Gen AI came out, we weren't as fast. I'm not talking only about Slovenia. I forgot to mention that I cover Slovenia and Bosnia. I'm based in Ljubljana, but okay, it's a little bit too late for that. But when Gen AI came out, everyone was interested initially. We were a little bit skeptical, countries here in the region, and there was still like the delay going on and a lot of skepticism. But I'd say that at least in Slovenia right now, there's a lot of companies and organizations that are willing and actually have the priority to implement generative AI. So the time frame, which I mentioned before, that it's usually 2 years and something, right? It's a lot shorter because we see, what's going on in the West, and we can actually see that that the companies that are going to be, the fastest ones to adopt this technology will have a great edge compared to the competitor. Okay. So my point is that although this is happening right now in Germany, UK, and US, we can expect the 29%, 29% mark to be applicable to Eastern European countries as well as, essentially for Eastern European countries in the next 1 to 2 years, basically. We'll see how that goes, but everything is going in that direction that that's going to be the case. Also when I talk with my other colleagues. So, although I promised I'm not gonna spend too much time, I already spent way too much time in this, on this slide, but essentially you get where I'm going at. You get the picture. Okay, so these are, some of the most common generative AI tasks implemented today. So we have summarization, classification, generation, extraction, question answering, code generation, translation, and language translation. But essentially, the main tasks, which are what's the word, low-hanging fruits, let's say, but the easier to implement are usually something that revolve around not wasting additional time. So like time savers, essentially. Okay, so if we take into account, let's say in the US, for instance, they're already implementing, you know, quite sophisticated use cases when it comes to Gen AI. Here we are, you know, currently trying to implement at least something into, you know, the first use case into a company or into our organization. And those use cases are usually the use cases that are fairly simple to implement, and they're fairly quick to implement it. So nothing, you know, too much sophisticated. So, you know, if I give an example, one use case which is very frequent is external chatbots, which are based on large language models. And, you know, also you implement other integrations, and then it's for external users. The customers can actually talk with a chatbot, and they can save a lot of money when it comes to, you know, there's multiple reasons, but one of the reasons is also that the client center is not losing their minds about how many people are calling each day, responding to emails, and so on and so forth. So, you know, the chatbots is a pretty frequent and easy use case to implement for external users. Then for internal users, you know, we have the different RAG, so retrieval augmented generation approaches, which is the most popular approach of, let's say, the most popular use case. And we create, let's say, different personal assistants or agents, or however you want to call them, for internal users, which are, the main objective is that they can answer questions, specific questions which are related to different working stations inside the company, let's say. Okay, so let's say we have different sectors. We have the HR sector, we have sales, we have legal, and so on and so forth. So in this case, we would, you know, train different large language models on top of certain documents which are specific for those three different domains. And then the employees would have an assistant next to them all the time that they can answer, that they can ask questions which are specific to the documents of that domain, right? So you can kind of imagine how much time that saves. Let me give you let's say one example is, you know, most knowledge workers. Now, the knowledge workers are the people that actually need access to certain information so that they can successfully complete their part of the job. Those are knowledge workers. So pretty much I'd say 99% of the people that are currently watching this presentation. So the average knowledge worker spends around, I think it's around 80% of their time just searching for information, okay? And then 20% is the execution, okay? So if we can lower the 80%, if we can lower it to 30 or 20 or even 40, right? Then you can get an understanding, you know, what the impact of that might be, right? And the future, you know, they'll have a lot more time left over for the execution part, right? And also the trends and everything points to the conclusion that these assistants and these agents are going to be more and more frequent in the next couple of years. Okay, so it's safe to say that in 5 years, for a new employee will be a knowledge worker, will have access to at least one or two agents slash assistants that they will be able to ask for help, right? No matter the domain and no matter the industry, by the way. These are not specific. They can be implemented anywhere. Okay, let's go. I've been setting the stage for way too long, so let's jump into the generative AI stack. Okay, so specifically, I'm going to be talking about what IBM's response is to the whole generative AI narrative that's been going on for the last two and something years, right? So I'm going to quickly introduce the tools, and then I'm going to be talking about one tool specifically. We're going to go over all the functions, and then also I'm going to be showing you the demo so you can see how the entire thing works in practice. Okay, but essentially, let's start with the first layer. So infrastructure. Okay, everything runs on Red Hat OpenShift. and we have a hybrid cloud deployment. Okay, so watsonx watsonx has a hybrid cloud deployment option. So whether it's on-prem, whether it's on cloud, or whether you want something in between, everything is doable. Okay, and this is crucial, especially for highly, we don't have everything. I mean, we have everything on cloud, but we also have it on-prem. And it's something that a lot of, highly regulated industries prefer on-premise. So it's something that it's something that's going to become fairly relevant, especially next year when the EU AI Act is enforced, because we can expect a lot of regulations, and yeah, so this is going to be a relevant topic next year. But anyway, some people have different preferences. Some companies can put everything into the cloud. Some people actually don't want, some companies and organizations don't want on-prem. It's because, they find that the cloud is easier and cheaper, but it depends on the preference, it depends on the use case, and so on and so forth. Okay, but we have all of these options. Then foundational model layer. Now, this is important because usually when we talk about big vendors and generative AI, the first thing that comes to mind is, okay, what's the model that this vendor is offering? Okay, if we take into account, I don't know, Microsoft, they have their own model, Amazon, they have their own, then Meta has Llama, and so on and so forth. Okay, well, IBM, although we do have our own model, which is Granite, right? Granite, I'm not sure how to pronounce that in English, Granite or something like that. I don't know, we say in Slovenia, we say Granite. But we have our own model, but that's not the main point, because our generative AI for businesses solution is essentially, we have a different strategy, right? And it's the multi-model strategy, so multiple foundation models. Okay, so here we see Granite, and we have more options. So we have Hugging Face, because we have a partnership from Hugging Face. So you are able actually to take models down from Hugging Face and use those models. Then we have a partnership with Meta, so you're able to use the Llama models as well as Mixtral. Okay, and you'll see later on I'm going to show you the foundational model library, where you have all of these models at your disposal, and you can use each one of those that you want, and also add others from Hugging Face. So why is this important? I'll go a little bit deeper later on. Okay, when I'm going to be showing you the demo. Then the third layer is Gen AI platform. Now, these are the three main pillars for Gen AI. watsonx.AI is the first pillar, okay, and this is the main part that we're going to be talking about today. So essentially, this is the studio. This is where all the magic happens. Okay, so data scientists, data engineers, and prompt engineers, and whatever you want to call the people that work in generative AI today. Though this is where everything's going to be happening. So testing the models, testing different prompts, use cases, fine-tuning the models, prompt tuning the models, the automative process of creating, certain machine learning models, whatever, pretty much everything's happening in this first pillar. Then we have the watsonx, the governance part. Now, this is the part for governing the models. And why is this important? Well, I'll explain a bit later, but essentially governance, especially Gen AI governance and AI governance as well, is something that's going to be very important, especially in the next year, because the EU AI Act is going to be enforced. And we also expect other regulations such as Data Governance Act and Data Act. Okay, so the quality of the data, the quality of the AI use cases is something that's going to be fairly strictly watched over by different, regulatory entities. So it's something that everyone inside of the European Union and, other companies that are going to be working with European countries in terms of AI, they're going to have to be, they're going to have to take these things into account. And these are the tools you can use to be compliant with the regulations, to make it short. Then what's next? The data. This is a data lakehouse. It's essentially where all the data is going to be saved, and that you will need for AI and BI and so on and so forth, right? It also has a vector database, Milvus, which is necessary. You need a vector database to implement RAG, so retrieval augmented generation, okay? So that's, for short. And finally, the last piece of the puzzle is the AI assistants, and these are all the assistants on top, right? We have different assistants where you can create a chatbot, then you have assistants that can create different internal agents. You have also assistants that where you create an assist, when you can create an assistant for specifically for code generation, then BI help for generating dashboards and so on and so forth, right? So the idea is that you'd have these assistants all over your business and they'll be able to do everything for you, okay? And all you have to do is just type in the natural language and that's pretty much it, okay? So you create a foundation with these three and then you attach the assistants on top and that's pretty much it. Now, we're going to be talking about mainly the foundation, and because I know that most technical people, this is what they are interested in, but more specifically about the watsonx.ai part, which is the studio where everything's happening, okay? So I know there's a lot of watsonx this, watsonx that, so it might be a little bit confusing, so I apologize for that. But it's essentially the best way to imagine all of this is that watsonx is an umbrella term, okay? And it's comprised of different models. So it's a modular framework, okay? And then it's not really a framework, but it's a modular solution. And then based on the client that we are talking to and based on their needs and the use cases they want to implement and so on and so forth, then we pick the correct models that they're going to need. And then with those models, we create different use cases, okay? So you're not stuck with everything, but you can basically pick the things that you actually need for your specific strategy and needs, okay? So IBM watsonx.ai generative AI tools, okay? Let's go into it. Okay, so here IBM watsonx.ai, build, train, validate, tune, and deploy AI models. So like I mentioned, this is where the magic happens. This is, where you can get your hands dirty and so on and so forth, right? So here, the watsonx.ai contains multiple tools, like a lot of tools I'm going to show you later on. But let's say the main ones are foundational model library. This is the foundational model library. This is the library where you have all the models. Then we have the prompt lab where you can prompt different models. You can see how they behave. You can test which are best for a certain language, which models are best for different use cases, and so on and so forth. Then we have the tuning studio. Here you can train the models on top, based on label data. You can fine tune the models, which is a little bit more complicated. You can prompt tune the models, and also we have an Instruct Lab approach, which is a cheaper way of fine tuning the model, because fine tuning can be a little bit expensive and it's not for everyone. But we're developing different approaches to fine tuning the model essentially, and Instruct Lab is one option where we can make that happen. Then we have track AI models. So using integrated governance features to track model performance, compliance, and model lifecycle. So this is the governance part I've been talking about. Okay, so one of the necessities of 2025 of the EU AI Act is that every model, or at least the models that will have a high degree of responsibility, every company will have to have a tracker on those models to make sure they're behaving properly. Okay, so these are also the tools that are encompassed. Okay, foundational model library. I think this is one of the most important parts, because as I mentioned, IBM's approach is to the entire thing is that sorry about that, foundational model, right? Okay, so IBM's approach to the entire thing is that we have a multi-model strategy. Now, why is that the case? Okay, the case is that the future is not going to look like you'll have one model that will be, covering every single use case. And there's multiple reasons for that. Like one of the reasons is that a huge model costs a lot. Whether you have it on-prem, it might cost you even, I don't know, I think the biggest models are up to, I think it's 8 GPUs. So that's, 8 times 40K or 50K, you can, that's that's quite expensive to run a large model like that, especially if you want to, implement every use case. If you want to have, 8 GPUs for multiple models of that size, that's not really a good strategy, right? So then you have smaller models which cost you, 1 GPU or 2 GPUs. Those are a little bit, better to maintain, right? And although they're smaller, they have other benefits. But essentially, price is one of them, right? So even if you have it on cloud, if an API call to a larger model is a lot more expensive compared to a smaller model. Okay, so smaller models are a lot cheaper at the end of the day. That's the first part. The second part is a large model has a higher chance of hallucinating. Why? Well, because it's trained on a lot of data. Okay, so you can imagine if a model was trained on, the majority or, a huge chunk of the internet, then you can imagine that it's going to know a lot of topics. Okay, so when it will come to, a specific example that you're going to ask the model to answer a simple question, it will have a lot of different topics to choose from. And the chances of the model hallucinating is a lot higher compared to, let's say, a smaller model who's specifically trained on that specific sector that you'd want the answer from. Okay, so smaller models, we have also multiple models, third-party models, original IBM models, and open source models, which were specifically trained on data from a specific sector. So one example might be, let's say, we have a model that's been trained on top of private data that is from private data that the example of the private data is, I think, in the financial sector. So case studies, doctor studies, and academic papers based on the financial sector, right? So also on documents which are specifically in the financial sectors, you can kind of imagine you have like a financial sector small model which can handle pretty much the entirety of that sector, right? So if you ask it a question, which is relevant to that sector, is going to give you a nice answer, but it won't give you an answer. Let's say if you ask it who won the NBA championship in 1993, okay? Because it wasn't trained on top of the data. But you can make sure that the answer to the questions that you'll ask it specifically, which is relevant to the document, is what's trained upon. Those questions will have a really low percentage possibility of it hallucinating. Okay, so we mentioned cost and we mentioned hallucinations. Okay, so those are the things, right? So the end goal is that every company, every organization is going to be using multiple models for cost optimization and for the sake of making sure that the models are behaving properly, right? The big model for every use case is a no-go. I mean, it can be done, but there's like risks involved and there's also a lot of money involved. Okay, so here we have different models, right? So third party, but yeah, I already spent way too much time talking about these slides. I'm gonna go a little bit deeper later on. We're gonna show you how these things look in practice. But let's go to the second slide, which is prompt lab. Okay, so here you can actually you can chat with the model. So initially you have the model library. You can pick different models from the library, and then you can chat with the models, and you have different approaches of how you want to chat with the models. So you have the generic chat, right? You can see here provides conversational interaction with large language models. So you can actually ask it, different things and see how it behaves. It's sort of similar as if you were to use ChatGPT, except, you know, it doesn't have a lot of pre-built-in prompts. So the answers are going to be a little bit, you know, they can be a little bit riskier from time to time, so you can, because it doesn't have so many guardrails set up. You can set them up yourself later on, but it's sort of done, you know, it has to be as raw as possible so that then the developers and the engineers can kind of create the use case that they want. Okay, so that's the chat part. Then we have the structured part. The structured part gives you an examples and templates of different use cases, such as, you know, for content generation, summarization, classification, for, you know, different domains, you know, marketing, and so on and so forth, essentially. Okay, and then the free form is for more experienced users who apply prompt tuning best practices for their use cases. So here you can basically apply different prompt tuning approaches. So you can kind of test out and set up the guardrails, set up the rules of how you want the entire thing to behave. Okay. So yeah, this is the chat. This is how it looks like. Essentially, you have multiple options to choose from. Here you have a bar where you can ask different questions. Then the structure format. You can see here the different templates which you can also choose from. Here are the different templates which you can choose from. And then here's the essential template, and you can put the input, and then you have the output, and so on and so forth. And yeah, let's jump into the prompt lab. Okay, so the prompt lab is, wait, for example, system for application. Oh no, sorry, my bad. Okay, so now jumping to the lab yet, but essentially here in the end you have you can essentially save the work as a prompt template, a prompt session, and a Jupyter notebook. Okay, so the prompt session allows users to access the history of the change. The prompt template pretty much saves the entire prompt except for the history. And you can also change the prompt. You know, once you're done with the prompt, you can translate it and save it as a Jupyter notebook, you know, Python file. So then you can continue on if you want to do some more specific changes, which in most cases you will be doing, you know, if it's a more serious project and if you're not just playing around. So you have multiple options to choose from. Yeah, and finally the freeform option. So this is for more experienced users. Now, when it comes to tuning, we have multiple approaches and multiple tools. We have fine tuning, which is the part where you actually change the weights of the model. Although this approach is a bit, from my experience, it's not that frequent that companies in EET, so in Eastern Europe territory, are going to be willing to fine tune the models because it's fairly expensive and it's not really that necessary, at least for the use cases that I was involved with. So this is not really a popular approach. Prompt tuning, on the other hand, this is a bit different. Okay, so it's a lot cheaper, it's a lot easier, it's, you know, fairly quickly to do. And you are not changing the weights of the model, but you essentially train the model with labeled data, but the model doesn't change. It does not change in its core. Okay, it's a lot cheaper. The results are not as good, but you know, you kind of have to like outweigh the price as well as the how much you want the model, you know, to perform. But you can come up with pretty good results even with prompt tuning, like really, really good. Okay, you don't have to fine tune anything. And then you have InstructLab. So InstructLab is a different approach. It's an open source approach where you can sort of fine tune these models in a cheaper way. Okay, so what I wanted to get, you know, I'm not going to go deeper into these things, but essentially you have multiple ways of tuning these models as you please. And also, you know, you can use retrieval augmented generation, which we also have a couple of different approaches, which, you know, different tools that help with the process. Tuning Studio, okay, this is when you fine tune them. Prompt tune the model. Here you can, which models do you want to prompt tune? You select the model, you set label data, and you create the task that you want to, what is your goal? Why do you want to fine tune prompt tune the model? You select the task, and then you get an output which is um, in line with all of these requirements. Synthetic data generation. Now, you also have different tools. You can kind of see, like, here we have a canvas, and here we have different nodes or widgets or whatever you want to call them, and you can kind of like drag those things on the canvas, and you can you can synthetically generate new data based on old data, based on different documents, and so on and so forth. So you can then use the synthetic data for the AI use cases. Okay, so this is also something that's going to be fairly popular in the up and coming years. And you also hear more and more um, more and more talking and debating around synthetic data. So this is also something that's already available on the platform. You can chat with images, you can upload images, and then the model extracts the, or sort of like explain what's on the image. This is fairly important when you're doing different retrieval augmented generation approaches. If you have documents, let's say, that contain images, such as different manuals, let's say for a telco use case, if they have different manuals which are relevant, revolve around resetting a router. Okay, so usually those manuals have picture, you got to click this number one, you got to then unplug number two, and you got to do something on number three, right? So you have an image as well as text next to it. So these models are extremely beneficial because they let you to understand the entirety of the document, not just the text part. Okay, so that's something to keep in mind. And finally, we have the watsonx.ai agent builder. Now, this is going to come out at the end of this year, but essentially you will be able to build your own agent, and this is also a topic that's quite popular, and we're going to be hearing a lot of it in 2025, right? So we have a lot of other tools which I'm going to be showing you now in the demonstration. So let's go into the I'm going to go to the IBM Cloud now, and I'm going to I'm going to open the watsonx.ai studio, and I'm going to be showing you how these things look like in practice. Okay. So once I'm done with the demo, I have, I think, 2 more slides or something, and then we're going to be done. Okay, so here, welcome to watsonx. Learn how to find what you need to prepare data and build models. Experiment with foundational models, deploy your models, and govern them responsibly. Okay, so I can click on take a tour. I'm going to click on next because I already did this, multiple times. But essentially this is how IBM watsonx looks like. Okay, so watsonx.ai specifically. Here we have an option, chat and build prompts with foundational models. Here you can tune the foundational models with labeled data and request or track models in AI use cases. Okay, so from this model, from this studio, you can connect all of the other models I've been talking about, modules, my bad. You can connect all the other watsonx modules I've been talking about before. This is the governance part. And you also have the data part and the assistance as well. So here's where everything happens when it comes to operations, testing data, and so on and so forth, testing the models and similar use cases, right? So I'm just going to jump into the projects. I'm going to create a new project. I'm going to call it DSC Europe. Give it a description, 1 to 3, doesn't really matter. And I'm going to create the project. So essentially, a project is a workspace where you can add different people, different collaborators, which work on the same projects. And you can, of course, you can give them different rights, whether or not, rights, that I don't think that's the right word, but yeah, rights or privileges or whatever you want to call them based on their function, right? So whether or not they can change the assets, they can change the assets, they can use the model, or they can change the prompts and so on and so forth, right? So it's a team environment. It's quite, it's a thing that's quite necessary for a business context. So here we have different jobs. These are here we can manage, access control. That's what I was aiming at. Yeah. So here we have access control. We have different environments. We have the resource usage if we're using the cloud, and services and integrations. Now I have to associate the service here for the entire thing to work. Here it is. Click on associate. And now I'm going to go under assets and we're going to see the different tools. Okay. So here we have chat and build prompts with foundational models. This is the let's say the prompt lab. Okay. We're going to be, this is the first thing I'm going to be showing you. Then we have ground Gen AI with vectorized documents. Okay. So this is an example of how you can prepare a retrieval augmented generation approach in a fairly quick way, right? Then you have different data sources. You connect to different data sources, and this is the same as before. You can prepare and visualize data, define reusable sets of parameters, and here we have the generate synthetic tabular data. You can build machine learning models automatically. Now, this is also something I'm going to be showing you. This is quite impressive as well. But I'm not going to go over all of these, one by one. Let's just jump into the first one. So chat and build prompts with foundational models. Okay, so this is the chat window. Okay, so here I can ask the model with whatever whatever I want. So hi, how are you? So I'm using llama. Okay, safe, good. So here in the top right corner, we have model llama guard 311 billion parameters vision. Okay, so this is the llama that's specifically designed to understand images. Okay, if we take into account, if you click on this part and I click view foundational models, these are all the foundational models that I currently have at my disposal. Okay, if I click X on the filter, we can see that, I have a lot of things at my disposal, and, also it's important to not forget that we can also, if these models are not, are not something that we are okay with, or that we would like to use something else, we can also use the, what's it called? The Hugging Face. We can use models from Hugging Face and then use those models inside of the studio. Okay, so we're not limited to only these models, but even these models are quite, they cover all of the not all of them, but some of them cover all of the EET languages. So the language isn't a problem. Maybe some of them are a little bit, are a little bit bigger. So we also have on Hugging Face different models which are specific for certain languages and are smaller. So that's something, each one of you will have to test for yourself. And yeah, essentially that's it. Okay, so this is the multi-model approach I've been talking about. So we have Llama, which one should we use? So Llama 3, 4, or Llama 2. This is the vision one, Llama 2, 3 billion parameters. Which one? Okay, let's go with Llama 3.170 billion parameters. Okay, here if we click on it, you have all of these, different parts of the information. So you have the model information, you have model architecture, supported languages, model release date, all of the information that essentially is needed also later on for the regulatory compliance and so on and so forth, right? So hardware and software, training data on top of which data it was trained, all the benchmarks and yada, yada, yada. Okay, let's click on select model. Okay, so here, like I showed before, hi, how are you? You can test these models out, you can see how they behave and so on and so forth. You have the chat window, you have the structured option, okay? The structured option, you have different templates here. Where is it? Okay, so different templates for summarization, for different use cases where you can try out. And essentially, it already comes pre-populated. So then you can just tweak a little bit, although all of this is in English. You can select the model which best suits, the language or the specific domain that you are trying to build the use case on top of, and then you can select, you can change these examples and see what fits you best, essentially. So this is something that the engineers and data scientists will have to test out for themselves, because there's a lot of options from here to choose from. And also you have code generation and other functionalities. And then finally we have the freeform option. So the freeform option is the option where you can test out different prompts. It's a little bit let's say, harder to use. I wouldn't say harder, but you need a little bit more knowledge to know what you're doing here. But essentially the idea is whatever you type, and then you click on generate. So whatever you type, the next word is going to be the word that has the highest likelihood based on what you already put inside. So in this case, if I click on generate, it's going to generate words which have the highest likelihood based on whatever I already typed. So in this case was whatever you type first will be the. So it's quietly, there's no prompts involved. That's why it's called free form. It's the raw approach to the model. Okay, so here you can also set different parameters here to make sure that it's behaving the way that you want it to behave. So whether or not you want the model to be greedy or sampling. Okay, so if you want the model to be a little bit robotic, or do you want it to use a little bit of its imagination, but at the same time risk it hallucinating a bit more often. So that's also depends on the use case and so on and so forth, right? But the plus side is that it's going to give more human-ish answers. Okay, so one example. Then you have repetition penalty. You can select the stop sequence. So when it outputs a certain words, when it outputs a certain word, then the generation of the response stops. And then you have minimum tokens and maximum tokens that you want the response to be. Okay, then what else do we got here? I think if I put on sampling, we get multiple other parameters. So temperature, top P, top K, random seed, and so on and so forth. Okay, and once I'm done with the prompt, I can save the prompt. And as I mentioned before, I'm going to save it as a standard notebook. Okay, so let's go with DSC Europe. And it's going to save the prompt as a notebook. So then I can continue on and work from there. Okay, so this is roughly of what I wanted to show you in the prompt lab part. So here we have the notebook saved. If I take a look, also, watsonx.ai has open source technologies such as Jupyter Notebooks. So you can use the Jupyter Notebooks, also from this tool. So one thing I forgot to mention is that we are not limited to only generative AI with watsonx.ai, but you also have tools that cover let's say for traditional AI and traditional machine learning, you have tools that cover the entire AI lifecycle. Okay, so from preparing the data to deploying the model to monitoring the model and the entire lifecycle with other steps that I didn't mention, but you get the idea. Okay, so even it's not just for Gen AI, but it's for other for traditional AI-based solutions, technologies as well. Okay, so let's go back to the assets. Now, if I click on new asset again, the other thing I'd like to show you is, okay, ground Gen AI vector-based documents. Then we have build machine learning models automatically. And we also have chat and build prompts of foundation models. Already saw this. We have R, right? We have R scripts and we have Python. And we can also automate the model life cycles, right? And we also have other options, but one thing I'd like to show you is build machine learning models automatically, okay? So here, essentially, what you need to do is you create a project, an Auto AI project. You create the Auto AI, not project, my bad, but experiment. You create the experiment, and then you give it a data set. Okay, so before I went to Kaggle, and I was searching for a customer churn data set. So let's telco. Okay, telco, which data set, yeah. So I'm going to be downloading this customer churn data set. I already have it downloaded, but okay, that's good. And I'm going to be showing you how the entire thing works in practice. So here I have this CSV, and I click on browse. I click on the data set. And okay, so create a time series analysis. I'm going to click on no. What do you want to predict? So here we have the different, I should have visualized the data, but I'm going to quickly explain what it contains. But these are the different columns that we have, at our disposal to choose from. But here we have the churn. And that's what we want to predict. But essentially, now we can run the experiment. We also have some experiment settings, but that's not really, I mean, it is relevant, but we don't have the time. But yeah, what I wanted to show you is that the Auto AI experiment. So here, essentially, it automates the entire machine learning, the entire machine learning pipeline for you. Okay, so all you have to, everything is automated. So all you have to provide it with is the data set, as well as which column do you want it to predict. Okay, so now based on the data and based on the column prediction, on the column that you want it to predict, it's going to do different types of experiments, and then it's going to optimally pick the correct algorithms, the correct transformations, which are have the highest accuracy in this specific situation. Okay, so this is more for traditional machine learning models as well as AI. I mean, as well as traditional AI, but this is something that's going to be also relevant for Gen AI as well, because it's also something that's in the works, and it's something that we can expect at the end of this year or maybe at the beginning of second year. Okay, but you will be able to automatically generate the retrieval augmented generation process in a pretty, a lot of the things are going to be automated. I'm not exactly sure how that's going to be working how that's going to work in practice, but as you can see, it's popular, the no-code tools and low-code tools are becoming more and more popular, and automation is something that all of, even from my personal experience, all of the companies and all of the organizations, they don't have like, um, they don't have people with a lot of skills, and they want, everything that does the job for them is essentially beneficial, okay, that makes their life easier. So it's going, at least IBM is going to the no code and low code generation, and that involves AI and traditional and generative AI, right? So essentially, okay, here I put in the data set, I put in the column that I want to predict, and now it's going to generate multiple AI pipelines, machine learning pipelines, from which I'll be able to choose different pipelines. And here we have the progress map, not view log, my bad. And we can see that it's starting the Auto AI experience. This is going to take a minute or two. And here we have this is the progress map. So we're at the beginning. So read the data, then it splits the holdout data, it reads the training data, then we have the pre-processing part, and finally the model selection. And if we go to the relationship map, we have this nice little, animation that's going on, and it should be done any moment now. Okay, there we go. So here it already read the data. Now it's the second part when it's going to split the whole of data, and then it's going to read the training data. And if we go back, you can see it split the training data into three folds. No, altogether, all the data. Yeah. So the training data was split into three folds, and it took 90% of the data set. And then the 10% of the data set is going to be used for evaluating the results. Now we're at the model selection process. So apparently here it's going to be used, we're going to have two different algorithms and different enhancements. So hyperparameter optimization and feature engineering, which are all based on these specific, on the data set. So, okay, so the algorithm was snap random forest classifier, and one pipeline was already generated. And we can see that also based on the data set and the column that we picked, it picks the optimal evaluation metric that is the best suited for the specific pipeline. So if we come to the pipeline comparison, we have different metric charts, which are relevant to the model pipelines. And in this case, we only have two pipelines generated, but in the end, it's going to generate 8 different pipelines, and then we can pick whichever one we want. And usually, of course, we pick the one that's the most accurate. So, this is going to take a little bit more time. So let's click on one of these. We're not going to wait until the end. We can save it as a model or as a notebook. And if you save it as a model, the process is going to be similar to the ones that I showed you beforehand. Okay. So essentially, this is what I had planned for, wanted to show you. We could also use, tune a foundation model with labeled data. This is also quite straightforward. DSC Europe 1, 2, 3. Oops, wrong button. Create. Which foundation model do you want to tune? You select the model. Now I have, let's go with Granite. How do you want to initialize your prompt? Text, random, whatever. You can upload the label data that you want to tune the model with. Which task fits your goal? You select the task that fits your end use case the best. And then on top of that, you create, you basically prompt tune the model. So that's kind of the end of that. Okay, so that's pretty much it for the demonstration. So I'm going to be jumping back to the presentation, because before I finish, I have a couple of more slides. Now, for everyone interested in these tools, you can either, you can contact me directly. You can go on the IBM Cloud website and you can test these tools for yourself and see how they work and so on and so forth. Or, if you have whatever question, you can just, message me directly, or we're already going to have some free time at the end of the presentation for that. But essentially, for the interactive demo, you can go on the web page, but I'm guessing I already did that. But some customers or have more specific requirements of what they want to see. So we can also arrange something like that. And of course, the GitHub to the Instruct Lab, which allows our users to fine-tune the models in a more cheaper, more effective way. Okay. One topic which I wanted to address, which is also quite relevant, is the EU Artificial Intelligence Act topic. Now, why is this topic relevant? It's relevant because it's going to be enforced next year. And for companies and organizations that already are using AI or are planning on using AI for next year or for the future, this is a topic that you need to be aware of, because this legislation is quite rigid, and there's going to be a lot of regulations that not most of us, but every single company inside of the European Union is going to have to abide by if they will be if they have a serious AI strategy in place. So here you can see we have multiple parts. The document's quite long, so these are briefly what what are the things that we have to take into account, right? So high quality training data, that's something that all of the companies will have to stick by. Then establish documents and design logging features. Establish documentation and design logging features. So the documentation revolving around all of the use cases, all of the data will have to be monitored all the time, will have to be saved somewhere. So when then an audit comes, the companies will be able to respond to and have everything documented about how the models were generating content and so on and so forth. So you will have to pretty ensure appropriate certain degree of transparency, ensure human oversight, measures built into the system or to be implemented by users, and ensure robustness, accuracy, and cybersecurity. To make things short, also, watsonx has a module for governing the models and all of the AI use cases. And you also have, not to be biased, but you also have other tools. But for everyone watching, make sure that you're familiar with the EU Artificial Intelligence Act, because it's something that's it's going to be it's going to be quite talked about in the next year. I think it gets enforced at least to some degree in October, if I'm not mistaken. So, if you're also interested in addressing this act, or if you have any other questions, you can feel free to ask me, and either now or at the end of, you can send me an email or contact me via LinkedIn, whatever you want. So thank you very much for listening. And I think I'm going to finish off with the presentation right now. So again, if you have any questions, feel free to ask. I'm going to I think I have to leave it to the organizers. Hopefully, they finish the technical issues. If not, then you can just type in the chat box to what I have to do from here on forward. So
Erik, can you hear me?
yeah, I can hear you. Yeah, thank you.
Okay, thank you, Erik. It was very interesting. And thank you everyone for watching this tutorial. We will have a short break now and see you back here at 3:50. So that's for now.
Okay. Thank you very much, everyone. Probably if there's any questions, feel free to contact me via via the email or LinkedIn, considering we have to go. So thanks again, and see you next time. Bye-bye.
Bye-bye.